So I'm with Francoise who oversees this conference. So we just want to talk about the general trends in bioplastics. But one thing I didn't quite gather, there's a decline in bio-PET. Why is that?
So bio-PET, it used to be a market which was predicted to grow very fast because Coca-Cola had put a massive effort in what they call their plant bottle. So they were proclaiming that a lot of bottles were already made from bio-PET. Then when we went back and checked the actual production facilities, it turned out that the majority was just normal, regular fossil-based PET production capacity. And the bio-based PET production, although it was forecasted, in reality never came through.
Wow, so it's all on the action of one company then?
Mainly yes.
Okay. The other thing that came through in those stats this morning was, well, two things came through. Packaging is still the largest sector, but has kind of gone into reverse. I assume that's not necessarily to do with bio-based, but just to do with the general kind of antipathy to plastics, full stop. Is that right?
Yes. So what we see in the bioplastics industry is that those plastics which are used once or in plastic packaging, so the single-use items and the plastic packaging items, they are the most visible. They are also the most scrutinized by the public opinion. And as a reaction to this scrutinization, there is the consumers, but also the brands, demanding more sustainable alternatives than what they have today. And they choose both the options. They choose lower carbon footprint, renewable, bio-based packaging in a lot of instances. And they also choose, where applicable and where feasible, for biodegradable, compostable packaging to reduce the impact on the environment and to facilitate the collection of organic waste.
So this is good news for compostables, and there is growth there. And it sounded yesterday as though the EU directives were more inclined to think and consider bio-based solutions now than they were, let's say, when they rushed through the single-use plastic directive.
Yes, so it's clear that the Single-use plastic directive was very much focused on preventing littering, and this is mentioned a few times. Even if you have a bio-based or a biodegradable plastic, you can still litter it, and you should not litter it. And therefore, in Single-use plastics directive, this was completely separated. On the other hand, there is some applications which have a higher tendency to leak into the environment. So we can think about mulch films, we can talk about the plants, the clips used to hang tomato plants in the agricultural process, but also fishing gear, fishing nets. Okay, there the Commission says, well, we should check and investigate options for biodegradable materials.
Okay. Let's switch to Total Corbion. You're going a storm in Thailand. Another 40,000. This is a third, increasing capacity by a third. What's driving that?
Yeah, so basically the whole debate around bioplastics or around plastics has triggered buoyant demand for bioplastics. One of them being PLA, and currently the market for PLA is very short. There's not enough PLA production capacity available to serve all the brands and all the consumers that want to convert to PLA. So there's actually a kind of a shortage in the market, and in order to mitigate this shortage, there is planned expansions for capacity. I must say that the 40 kiloton is an expansion of the lactic acid capacity. So it's the raw material that we use to make PLA. Okay. And our capacity for the moment remains at the 75,000 tons, which we announced some time ago.
Just divide those figures up for me. So the 75,000 tons is PLA produced. The 40,000 tons is lactic acid to produce the PLA. Correct. But the beer volume of PLA produced will obviously grow and go up. Do you know by how much?
I don't know the exact figures. I mean, we started up our 75,000 ton plant last year. Right. We think that this year we are around about 1/3 full. Next year our estimation is we will be 2/3 full. and then the years after we'll probably be at full capacity. And one of the things we need to unlock full production capacity volume is enough lactic acid. So that's also why Corbion is investing in the lactic acid.
Okay, I've got it. So that 40,000 tons lactic acid increased capacity will go to realise the 75,000 tons. Okay, PLA. Thank you for that. Okay, the life cycle analysis. You referenced it to start with by saying there were 16 different criteria, and you went for 8 of them. Is there any significance in that?
Yes, so there is in the methodology for a life cycle analysis, or life cycle impact assessment, I should say. One of the first things is to say, well, there is 16 categories that you should consider, and then you should add them and weigh them, and then you get a kind of a overall indicator of your environmental impact. Okay. And you need to choose then those factors which make up 80% of your environmental impact.
And
those are
the 8 you chose.
The 6 we chose were those added up to the 80%.
Yeah.
And then we added 2 which actually had a very low impact on our product footprint from an environmental point of view, but we still studied them, which is the water scarcity and the non-renewable energy. Means actually that if you look at the PLA, the water impact according to the LCA analysis is not considered to be significant.
Okay.
But still we chose to study it because we get questions on it.
And in the factors that you didn't take into, I mean, does that leave you open to somebody saying, well, you haven't done a full assessment because you didn't cover all the bases?
Well, actually, it's interesting because you have to calculate all of them before you can actually say that that these are the ones which have the least impact.
I see.
But then what you do is in the rest of the study, you try to firm up, let's say, the data around these factors. And very important, and often people forget it, we do the life cycle assessment also to check where and how we can improve. So it's not only to report the low carbon footprint number, which is nice for the brochure and for the brand owners, but we want to know how this is built up and how we can further reduce it by improving our processes. But for this we need to know the different steps and how it's built up, and that's why we can say, hey, if we would go to a different production technology for the lactic acid, we would reduce so much on the CO2, and so much on the energy, and so much.
So you have to take those things into consideration in order to discount them in the calculation.
Yeah.
Okay. Zero CO2 footprint when PLA leaves the factory. That's actually a negative of 1,000.
Yes,
that's
very exciting.
Some aspiration.
It's very exciting and very inspirational, I think, as well.
Yeah.
And the other thing is, so I was really closely involved in making this assessment. That is not at all impossible, and most of these things will happen by themselves because it's only logical that in Thailand they want to go for a higher yield of the sugarcane. And if you look at the statistics, they improve the yield per hectare every year. So it's just a few years out and they will have made that improvement. Then the energy recovery at the sugar mills, well, that's energy recovery, that's pure money for the sugar mills. So they're going to do that investment and have a fantastic payback on it. And while doing it, they will improve the carbon footprint of PLA. So that's going to happen without any further actions or coordination needed. And
it kind of sounds miraculous because you're increasing production, but you're reducing carbon footprint.
Correct.
Which is completely counterintuitive because you'd think.
On one hand, yes, but in reality, actually not, because you can look at the LCAs in different ways, and you can also look in a carbon footprint in different ways, and in the end it's the very technical CO2 global warming potential CO2 equivalence per kilo of product. Very technical. But if you look in the analysis, you know that every time when you use energy, every time when you waste something, you get a negative. Every time you do a process using less energy, or producing less waste, you improve your carbon footprint, so you come to a lower number. So actually the life cycle analysis helps to identify which parts in your production process you should optimize to have a lower cost product. And by as a present, you get a lower carbon footprint.
I have to assume that a really attractive life cycle analysis result enables you to sell more PLA. That's got a bigger point, is it?
Yes, yeah. I mean it helps, and it also helps for our customers to be able to make credible, substantiated claims when they buy the product and say it really helps to reduce the CO2 emissions. So then they have data to really show that it does.
Is there a finite number of times PLA can be recycled mechanically?
That's difficult to say. We've done studies where it can go up to 5 to 8 times mechanically, and after that, it's still possible to recycle, but you will be more into the downcycling.
Okay, last question. Going back to your 40,000 tons of lactic acid capacity, and we talked briefly about chemical recycling as a way of producing lactic acid. So to what extent will chemical recycling play a part in developing that 40,000 ton added capacity?
Well, for every ton of PLA that we produce, we need the raw material. So we need lactic acid to make a ton of PLA. Yeah. And if we can get the lactic acid made from sugar, that's good. We showed this in the life cycle analysis. But if we can get this lactic acid because we have PLA coming back from the consumers and we make it back into lactic acid, that's even better.
It is exactly a ton for a ton, is it?
Well, actually you need 1.3 tons of lactic acid for a ton of PLA.
And did chemical recycling play a part in your life cycle analysis results?
No, we didn't model that in because we went to the factory gate and we didn't model in the reusing. But it's a good point that if we would use 5 to 10% post-consumer recycle as a feedstock for our PLA, our life cycle analysis would further improve.
That negative 1,000 figure
go even lower. Yeah.
And that's chemical recycling will do that for you.
Yes.
It was interesting to me because NatureWorks, I know we shouldn't really talk about, but I didn't seem as enthusiastic about chemical recycling as perhaps you are.
I got the same impression. Why are we so interested in it? I think that's easy to say.
All right.
When we built our factory in Thailand, the production engineers were planning and calculating also with some out of specification product. And the first idea from the production engineers was to sell it on the market. But then I came, the marketing team, and I said, we're not selling out of spec products, so you have to make a way to reuse it because we don't want to landfill all the product which is out of spec. Sure. So then the technical team came with a solution which they actually built and constructed. So our factory in Thailand has the equipment to do chemical recycling. And when today, tomorrow or last week they produced out of spec product, that is already chemically recycled. And for us it's a very small step to carefully add in maybe first a post-industrial stream of recycle, followed later on by a post-consumer stream of recycle. All the hardware is available, it's easy.
Thank you so much. Next year in Vienna.
Yes, looking forward to it.
All right, okay. Thank you, Francoise. Thank you very much.